Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. We're plugging right along with our surface area and volumes, and just like before, I'm going to talk to you guys about surface area up front. We're going to define it and give you guys the formulas, all that sort of stuff, but we're not actually going to be doing any examples because we got to focus in on volumes, and I didn't want to do too much in the little amount of time that we have. So, let's talk about the anatomy of a pyramid first. So, solid base, or it's a solid with a polygon base. We're always going to be naming the pyramid after its base. So in this case, it is a square pyramid. Actually, on this one, we've also got an oblique pyramid where it's not exact, the vertex is not exactly centered on the base. But a few things we want to point out. Base is typically the thing it sits on. Don't get hung up on that. Not always. Lateral faces on a prism, the lateral faces were all of those rectangles. On a pyramid, the lateral faces are all the triangles. And then the base is that non-triangular piece or face there on, usually on bottom. Altitude always at a right angle. Lateral edge is one of the edge that connects the bases with the vertex up here on top. Okay, let's talk about our regular pyramid. So exact same idea. One more thing I do want to point out, and that is this slant height right here. Whenever you have a regular pyramid where the base is a regular polygon, the slant height goes from the midpoint of a side up to the vertex. And what that means is that right here, you've got a right triangle going on where you have the height, the apothem, and then the slant height, which I'm sorry, we actually use an cursive L there. So those three can be used. Just realize that it is the apothem of this base because you're going from the center to the midpoint of a side. So lateral area is the area of all the triangular faces. And because these are triangles, it's going to be based on the area of a triangle, where the area of a triangle is just 1/2 times base times height. So it's a similar idea, and if we were actually in class, I would go through and show you the derivation of where that comes from. But suffice it to say, we're just going to give it to you right now. It's 1/2 times the perimeter of the base, capital P is perimeter of the base, times L, which is the slant height, which again connects the midpoint of the base up to the vertex. Now, if you wanted to find the surface area, all we're doing is we're using the lateral area and then adding in the area of the base. So here's our lateral area, L, plus B. So exact same idea. Now, cones, and if we can start thinking about a cone as a circular pyramid, then everything starts to work out and you have the exact same formulas, because for the lateral area of a pyramid, we had 1/2 PL. For a cone, it's 1/2 P. For a circle is a circumference, so that's 2 pi r times L. These two cancel, leave me with just pi RL. Then when we do the surface area, we're going to get, again, lateral area pi RL plus pi r squared for the area of the circle on bottom. So these things work out the exact same way as pyramids. It's just that they have a circular base instead of a polygonal base. Okay, volume of a pyramid. If we were actually in class, again, I'd have this cool little demonstration to show you that these things are actually 1/3 of their respective prism. Here's what I mean by that. If I was to draw all of these sides up and draw the prism out that was the exact same height, ironically, the pyramid is exactly 1/3 the volume of the prism, or which I think is actually kind of bizarre, is that this vacant gap here that's in white is actually double the volume of the pyramid itself. Anyway, all you're doing is find the area of the base times the height and divide by 3. Okay, it doesn't matter if it's a regular or an oblique, either one works. Now, for our circular pyramids, it works the exact same way. For a cone, it's just going to be volume equals 1/3 pi r squared h. Exact same idea. So let's jump right into our examples. Find the volume of this square pyramid. So volume is 1/3 area of base times the height. And just like before, we're going to jump over and do our area of the base on the side and come back to it. Area of the base here is length times width. Again, for rectangles, I don't care if you use length times width or base times height. Either one works. It's a square, so it's just 3 times 3. So area of the base is 9 inches squared. Now we jump over here. Volume equals 1/3 times area of the base is 9 times height of the pyramid is 7. Well, 1/3 times 9 is 3 times 7 is 21 inches cubed. All right, find the volume of this pyramid. Once again, volume is 1/3 area of the base times the height. So we're going to find the area of the base first. Area of the base. Now base is a right triangle down here, and so it's 1/2 base times height. Once again, make sure you're keeping very, very careful track of where your proper B's and H's are. Context, capital B is area of the base. Little b is base of the triangle. Now, since I've got a right angle here, looks like base of the triangle is going to be this 6. And then the height of the triangle is going to be this side, the one that is the altitude at the right angle. Now I've got to back up and find that. So we've got our a squared plus b squared equals c squared. And so we've got 6 squared plus b squared equals 10 squared. So that's 100 minus 36, so b squared equals 64, which means that b there is 8. So 1/2 times 6 is 3 times 8 is 24 feet squared. I know there's a lot of numbers thrown out at one time. Please feel free to use that pause button. You can get caught up. Or, hey, even go back and rewatch that if it was too fast for you. All right. Volume equals 1/3 times area of the base, 24, times the height of the pyramid, which is 15. Notice that's a right angle there. Let me erase this out. Notice that was a right angle, so we know it's the true height and not the slant height. So now we just jump in. 24 times 15 divided by 3. 120 feet cubed. Once again, make sure that your volume units are always units cubed. All right, this one is going to make you so excited. Volume of the pyramid, in this case it's a regular hexagonal pyramid. Now I'm going to go ahead and write my formula here. Volume equals 1/3 area of the base times the height. We're going to have to do a little bit of work to get the area of the base here. Since it is a regular polygon, the formula is 1/2 times apothem times perimeter, which then brings up, we got to figure out what the perimeter and the apothem are. So, well, I know it's a regular hexagon, so the perimeter is just going to be the length of the side times the number of sides. So it's 6 feet times 6 sides, so the perimeter equals 36. Okay, good. Now, let's talk about one of these central triangles, because I need that apothem right there. Well, I'm going to draw this a little bit bigger. I need this. I know that the full length is 6, but the apothem has the midpoint, so each of these is 3. Now, on a hexagon, let's see, the full circle around that central point is 360 degrees, but there's 6 of them. 360 divided by 6 is a 60-degree triangle. I'm sorry, a 60-degree angle. And since these two are both radii, then it looks like that's an isosceles triangle, meaning this is an equilateral triangle, so they're all 60 degrees. Now that's nice because that would mean as equilateral, each of these side lengths is 6 as well. That doesn't give me the apothem though. There's 2 ways of doing it. You could run your your Pythagorean theorem with 6 and 3, or you could realize that this angle up here, I'm going to go ahead and erase the 60 on top, that has been cut in half by the apothem. So this is actually a 30, 60, 90 right triangle with my side length being 3. Therefore, this length here is 3 root 3. That came from our 30, 60, 90 triangle being L, 2L, L root 3. Or you can use trig, however you want to get there, Pythagorean theorem, whatever you need to do. So the apothem is 3 root 3. So area of the base is 1/2 times apothem, 3 root 3, times perimeter, which is 36. So 0.5 times 3 square root 3 times 36. Once again, be careful making sure that you press right to get out of the fraction bar. I'm sorry, the square root bar. That way the 36 is not underneath the square root. So the area of the base here is 93.5307. So volume is 1/3 times 93.5307 times the height, which it looks like my height in the drawing is marked as 18. And now I just plug that in. 93.5307 times 18 divided by 3. Volume is 561.18 feet cubed. And this one didn't say, so I went ahead and went to the 100th. All right, now let's do some cones. We'd already talked about that. 1/3 pi r squared h, where again, this is just the area of the circle on bottom. So it still works the exact same formula, but I'll write it out this way because once again, it's more direct. Oh, sorry, went too far. All right, this one at first looks like we're going to have to do some trig until you realize that with the volume being 1/3 pi r squared h, and h is the true height, the perpendicular height, since we have a right angle right here, 25 is h. So we can plug this directly in. 1/3 times pi times 9.1 squared times 25. So that is pi times 9.1 squared times 25 divided by 3. 2167. Now this one says nearest tenth, so it looks like that's actually going to round up to 0.68, or yeah, 2168.0 feet cubed. And now, example 5, volume equals 1/3, no, not area of the base, pi r squared h, 1/3 times pi, looks like r is 5, and h is 12. That one was very straightforward. pi times 5 squared times 12 divided by 3. Nearest to 10th, 314.2 inches cubed. Sorry, the reason I paused for a second there is I just realized that 314.15926, that's pi times 100, or pi times, 100. That makes me curious. 1/3 times 25, because that was 5 squared, times 12. 1/3 times 12 is 25 times 4. Sorry, I should have put that 1/3 pi there. Yep, that is just 100 pi. Don't need that at all because it said around the nearest 10th. I just thought that was interesting when I saw those numbers. All right, here is an oblique cone. I guess it's not completely oblique, but it's definitely not regular. So once again, we've got this triangle here. We're given the 45. Now we're going to have to utilize our 45, 45, 90 right triangle here, where we have S, S, and S root 2, which means that my height here, H, is going to be 18 divided by square root of 2. Now, in most cases, I would need to convert that. Actually, I'm going to go ahead and do that, rationalize it. 18 root 2 over 2, which is 9 root 2. Now, let's do our volume is 1/3 pi r squared h. 1/3 times pi. Now, radius, we're given the diameter of 20, so the radius is 10 squared, times the h, which is 9 root 2. Pi times 10 squared times 9 square root 2, airing over to make sure I'm outside the square root, divided by 3. 1,332.9 yards cubed. All right, that's it for today. Hope you guys have fun doing your assignment. Take care, and as always, please stay patriotic.